Let me start to explain the discrete or linear convolution. As I mentioned in my earlier lecture, if x1n and x2n are two separate signals, then you can obtain the convolution between them by using this formula. Okay, m equal to minus infinity up to plus infinity. x1m, m is a dummy variable. Okay, and x2n minus m. Okay, n is the time index and m is the dummy variable, and this relation is true for the reciprocal case also. In place of x1 you can use x2, and in place of x2 you can use x1. Now if I mention that the length of the first signal x1n is capital N1 number of samples, and length of the x2n is the capital N2 samples, then what will be the number of samples or length of the convoluted signal? That means the x3n. x3nth length will be n1 plus n2 minus 1, remember. And this particular convolution is also known as the aperiodic convolution, because x3n will become necessarily aperiodic. Now x3n, you can notify the convolution operation by means of x1 star x2 or x2 star x1, because this operation is commutative operation. Now procedure of evaluating the linear convolution. First you can put time index equal to some other value, that is q, and in place of n you have written q here as well as q here also. Okay, and what will be the first step? First step will be to change the index of each signals from n to m. Okay, so change the index of x1 and x2 from n to m. Now the signals will become x1m and x2m. Second step will be to folding operation to the second signal, that is the x2. So x2m is folded to the x2 minus m with respect to the origin, that means m equal to 0. Next step will be the shifting step. Shifting step means now the folded signal has to be shifted by q amount. Okay, q amount you have to shift it. You have to provide the right shift by q. If the q is greater than 0, you have to provide a left shift by q if q is less than 0. That means if q is positive, then you have to provide the positive shift, and if q is negative, then you have to provide the negative shift. So your shifted signal is x2 q minus m. Next the multiplication, that means this multiplication inside the summation. You already have x1m, multiply it by means of the x2 q minus m, this shifted version. Okay, and consider the multiplication product as the vqm. And lastly you have to do the summation, sum all the values of the product sequence vqm. That means product elements means within this product sequence whatever the values will be there, whatever the elements will be there, you have to sum up them, and to obtain the value of x3n at n equal to q. That means by doing that you will obtain the value of x3 or convolution at n equal to q. Now you have to change the q value starting from the starting of the convoluted signal up to the end of the convoluted signal. Okay, how can you obtain the point where the convoluted signal x3 will start? That can be obtained by using this rule. If the x1n starts at n1, that means the starting time index of the x1 is n1 and starting time index of x2 is n2, then surely the starting time index of the x3 will be equal to n1 plus n2. Okay, that means first q value here you have to consider n1 plus n2, and at which value, up to which value you have to do this particular, you have to follow these particular 5 steps up to the ending point of the x3. Ending point can be obtained as n1 plus n2 plus n1 capital N1 plus capital N2 minus 2. Okay, it can be proved very easy way. N1 capital N1 and capital N2 are the length of the signals, and small n1 and small n2 of the signals, starting time index of the signals x1 and x2. Okay, so you have now the starting time index as the n1 plus n2 and the ending time index, that is n1 plus n2 plus capital N1 plus capital N2 minus 2. So if you have that individually for each and every time index of x3, you have to follow these 5 steps. Now let me tell you that, as I mentioned in my earlier lecture, that if you have an LTI system and your impulse response of the LTI system Hn is known, that is the Hn is known, then for any arbitrary signal xn you can obtain the response of the system by using the convolution. That means convolution of the arbitrary input signal and the impulse response will give you the response of the system. That will be represented by this formula, convolution formula, linear convolution formula. This proof is very easy. You can go through the proof from the book of Nagorkani. Now the properties of convolution. Convolution obeys generally 3 major properties of any binary operation. That is the commutative property, associative property, it is associative over the convolution again, and the distributive property, that means it is distributed over the summation or subtraction operation. Now interconnection between the discrete time systems, it is very important to understand, because if you want to do the block diagram analysis in the signals and system subject, or later in the control system, you will have to handle several block diagrams. So you have to know that what should be the relationship between the overall impulse response and the individual impulse response of 2 systems, 2 or more systems, if you connect them in cascade or series or in parallel. Suppose 2 systems are there. First one have the impulse response of h1n and second one has the impulse response of h2n. If you connect them in series like this way, that means output of the first one is given to the as the input of the second one, then the overall output will be related to the overall input by this way. That means now the overall system will become the impulse response of the overall system will become the convolution of individual systems. Okay, proof. For the proof you have to go through the book. Second, parallel connection. If the individual systems are connected in parallel via a summation block, then the overall system's impulse response will become the summation of individual impulse responses, h1n and h2n, the individual impulse responses of 2 systems, and if you connect them in parallel, then the overall system will have the impulse response of h1n plus h2n. Okay, and again for the proof you have to go through the proof of Nagorkani. Let me give you one example. Suppose determine the it is given that determine the overall impulse response of the interconnected DT signal, where the individual impulse responses are given here. These are all the causal signals, because signals are multiplied by un. Okay, first one is this one, second one is this one, and third one is this one. Okay, and the interconnection is given like this. Now simplify the interconnection by means of this way. Okay, it is overall input, overall output. Now see that overall input is fed at the input of the h1n system and h2n system, and again output of the h1n system is given to a summative adder, and output of the h1n system is given to that summative adder, as well as it is given to the final summative adder, and output of the second summative adder is connected to another system which has the impulse response of H3n, and output of the H3n is added with the output of the H1n actually, okay, and you will get the overall output. So this particular interconnection can be simplified this way. Here this particular region is clarified. Say that overall input is given to both H1n as well as H2n, okay. After that, both of them are added via a summative adder here, and output of the summative adder is given to the H3n like here, and output of the H3n is given to the one input of another final summative adder. And here, see that output of the H1n is taken from here and given to the output input of the final summative adder. So here separately we have taken the system again because it is equivalent, and output of the system is given to the final input of the final summative adder, and overall output is taken. Now individually from these two laws, from the cascade and parallel laws, you can determine what will be the overall impulse response of these two systems which are connected in parallel. That should be H1n plus H2n because they are in parallel. Now what will be the overall response of the impulse response of the system considering this parallel block along with this serial block? See that this parallel block have the impulse response of H1n plus H2n, which is connected in series with the H3n. So this much and this one should be convoluted in order to obtain the overall impulse response of this branch, okay. So H1n plus H2n convolution H3n, that is the overall impulse response of this branch. And the upper branch has already the impulse response of H1n. This upper block is in parallel with this overall block which has the impulse response of this much, okay. So overall impulse response of this total system will become this one parallel to this branch, okay. So this should be added with the impulse response H1n in order to obtain the entire impulse response of the system. And after that, put the values, individual values of these impulse responses here and simplify. Do this summation operation. It is using simple GP operation or the geometric progression operation in order to obtain the overall value, and from that you can simply follow this note and you can simply obtain the overall transfer function in the impulse response of the overall system. And you have to multiply it by un because all the individual impulse responses were causal, so the output impulse response will be also causal for all n. Now I am going to the method of performing the linear convolution. There are three methods. I will discuss all of those three. In examination it can be mentioned that which method you have to use to do the convolution. That's why you have to remember and practice all these three methods, okay. First method is a bit lengthy, but it will be elaborative, okay. It will be illustrative as well as elaborative, so you can understand in better way. But the second and third methods, those will be much shortcut methods, and you cannot understand the internal method, but output or the result will be same. If you have any competitive exam, suppose you have given two sequences and convolution has to be performed, you can follow either method 2 or 3 because there will be no mention of the method. But in the semester examination where the descriptive questions will arrive, there you can be asked to do the convolution by using a specific method. That's why three methods are important. First, two sequences are given, LTI system, input is given as starting at 1 2 3 1, okay, that is the sequence. and its impulse response is a non-causal impulse response starting from 1 to 1 minus 1 and the position of the origin here. Okay, so that means starting time index of the first one signal is n1 equal to 0 and the length of the first signal is the 4, okay, because 4 elements are there, n1 equal to 4, and the starting time index of the impulse response of the second signal is n2 equal to minus 1 because it is started its origin is here, that means its starting is at the minus 1, okay, and its length is again 4. Now the overall length of the convolution in between them should be n plus into minus 1, that means 4 plus 4 minus 1, that will be 7. Okay, now you have to first understand that what should be the starting sample of the convolution between them, yn. Okay, so starting time index should be n1 plus n2. So if it is n1 0, n2 is minus 1, then it should be n1 plus n2, that means minus 1. From minus 1 time index, the impulse response will the yn, that means the convoluted signal, will start. And what will be the ending point of this yn? You can obtain by using this formula, n1 plus n2 plus capital N1 plus capital N2 minus 1. As I mentioned earlier, if you do that, you will obtain 5. That means say that it will start at minus 1 and end at 5. That is minus 1, 0, 1, 2, 3, 4, 5. So 7 samples will present, and it is same because say that length of the signal is arriving as 7 samples. Okay, now I am explaining the method 1. It is called the graphical method. In the graphical method, follow the 5 steps, or rather 6 steps of the convolution, as I mentioned earlier. So first you have to change the time indexes from n to m. Okay, make both of the signals into xm and hm. Okay, so draw the signal, first signal, since it is 1 2 3 1, so at 0 it is 1, at 1 it is 2, at 2 it is 3, and at 3 it is 1. Okay, and the second signal was the 1 2 1 minus 1, where 2 is at the origin. So 2 value will be at the origin, at the minus 1 it will be 1, again at the plus 1 it is 1, and at 2 it is minus 1. Okay, so xm and hm are drawn here graphically, where the time indexes are changed to m in spite of n. Now the next step was to make it folded with respect to the origin. Okay, so if you fold them graphically, you can just get the mirror image by placing a mirror here. These things will be reversed to here, and this thing will reverse to here, like this. That is the folded image, folding operation you have done, and you are getting the h minus m. Okay, after getting the h minus m, now start from the n equal to minus 1, because you know that yn will start from n equal to minus 1, and you have to do the same things up to n equal to 5, because ending point of the yn is n equal to 5. So start from n minus 1. So you are actually performing convolution for n equal to minus 1. Those, that means you are finding the first sample of the y minus 1, first sample of the yn, that is the y minus 1. Okay, so in place of q, that is that shift version, that is this one, in place of q you are placing minus 1. Okay, you are placing minus 1. So you have to find out what will be the shifted version of the h minus m. H minus m was this. Okay, its shifted version will be 1 unit delay. So 1 unit time advancement. So that will be h minus 1 minus m, that will be just 1 unit left shift, this left shift. Okay, so if you draw this 1 unit left shift here, that will be here. Okay, so it is h minus 1 minus m, and you already have the idea what was the xm. It was the same, this is the xm. Okay, so it is xm, it is the 1 unit shifted version of the hm, h minus m. Okay, and multiply these two signals, because within the summation you have to multiply them. Multiply these two signals sample by sample. See that first sample of the h was at -3. Okay, but at -3 xm do not have any sample, so first sample -1 multiplied by 0. Okay, this one will be the first one. Next one, at a -2 h has the sample value of 1. Here again at -2 there will be no sample for the xm, so 0 multiplied by 1. For the next sample at -1, again it has the value of 2, but it do not have any value, so 0 multiplied by 2. At 0 it has the value of 1, it has the value of 1 again, so 1 multiplied by 1, there will be some value. But at 1 there will be no value here, but here it is the value of 2. Okay, so 2 multiplied by 0. In this way, for all other samples at the right side, you will obtain that since the sample values of h has 0 values, so all other multiplication values will be equal to 0. Only this was the non-zero multiplication value where both the signals are overlapped at m equal to 0. Okay, so y minus 1 will become 1. It is that signal. Okay, it is 1. Next you have to find out the next sample, that is the n equal to 0. So you have to find out y0. So for y0, in place of q you have to put 0 here, so that means it is nothing but the h minus m. Okay, h minus m was the same thing which was the folded version, this one. Okay, put it here, and again xm was already known, this one is xm, it is unchanged, so put them aside each other, and again do the same thing, sample by sample multiplication. If you do that, you will obtain it has two overlapping points. See that at m equal to 0 and m equal to 1, both of them has the values, but all other points left side, these have the value but these do not have any value, so those will be 0. Again for m equal to 2, 3, etc., these have the value but this signal do not have any value, so all of them will be equal to 0. So these two overlap time indexes will has to be amplitude multiplied. So 2 multiplied by 1, that will give you 2, and 1 multiplied by 2, this value was 2, so that will be again 2, so this value will be 4. Okay, in this way, for m equal to 1, again you have to calculate the same thing, you are calculating the y1. Okay, for that case you have to provide the right shift to the h minus m, 1 unit right shift. That means h minus m has to be shifted 1 unit by right side. So that is that 1 unit is shifted at the right side, and after doing the similar things you will obtain this y1 is becoming 8. Okay, considering the similar procedure, following the similar procedure, you can have the sample values of yn for n equal to 2, 3, 4 and 5, because after 5 again all the values will be 0, there will be no overlapping. Okay, so all the values can be obtained by using the similar procedure, and now you have the value of y minus 1, it was equal to 1, y0 it was equal to 4, y1 it was equal to 8, y2 8, y3 3, y4 minus 2, y3 minus 1. Okay, all of them has to be written as a sequence, and you know that at y0 it is the origin. Okay, so you have to put the up arrow below this sample, so it is that. Okay, so it is the convolution procedure, graphical method. So it is very easy to understand, but for a long sequence, two long given sequences, you have to perform very huge number of steps. That's why this procedure is very lengthy, but it is very elaborative as well as illustrative. Next method is the tabular method. Okay, for the tabular method, again you take both the signals. Both the signal means xn as well as hn, and now just change the time index of them from n to m. Okay, so you are writing xm and hm, and now put all the possible. You can start from -3 up to 6, 7 or 8. You can start from earlier also. Okay, so this row, first row, is the m row, that means the time index row, starting from -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, 6, 7, 8, etc. Okay, write it here. Now draw the columns according to the each time index values. Okay, now try to write the first signal. It was starting at, see that first signal was 1, 2, 3, 1 and starting at m equal to 0, and second signal was 1, 2, 1, -1 starting at m, starting at here. Okay, so starting will be for the second signal, starting point will be -1. So write those here. First signal starting at 0, 1, 2, 3, 1, and second signal starting at m equal to -1, 1, 2, 1, -1. Okay, now go to the next step. Next step was to obtain the folded version of this one. Okay, so right here, this is the folded version. Folded version means if you have this one, this column as the origin, then this total signal has to be mirror imaged. That means this thing will arrive here, this thing here, this thing here. Okay, this is the mirror image of this one. Simple. So you have written the mirror image here, that is the folded version of this one. After that, you have to write all shifted versions starting from n equal to -1 up to n equal to 4. Okay, so -1, 0, 1, 2, 3, 4, 5. For all the shifts which have already obtained in the graphical method, you have to write in this particular table. Suppose I am writing the h -1 -m. You know that this particular shift is nothing but the left shift. So this signal, that is the folded signal, has to be shifted left side by 1 unit, -1. Okay, this one is shifted left side by 1 unit. So it is becoming this one. Okay, now next one is 0 -m. That is same as this one. That is same as this one. So again write this signal here. 1 -m, that means the right shift. Okay, that is the right shift. So this signal has to be shifted rightward by means of a single unit. So it is shifted rightward here. And next one, right shift of 2 units. This one is right shift of 3 units. This one is right shift of 4 and 5 units. Okay, write all of them. Okay, so you have done all of the steps here. After that, you have to calculate first the y -1. That is the first sample of the convoluted signal or the output. Okay, that is this one. Okay, that means you have to consider this signal xm and the right shifted folded signal, this one. Okay, so considering these two rows only and ignoring all other rows, multiply column by column. All other columns other than the signal values are 0 considered. Okay, so this column -1 multiplied by this column, it will be 0. This column multiplied by this column, it will be 0. This column multiplied by this column, 0. This column multiplied this one, 1 multiplied by 1, 1. Only one overlap is there. Okay, and all other columns are 0 here, and multiplying 2, 0, it will be 0. 3 multiplied by 0 0, 1 multiplied by 0 0. Okay, so only the value will be 1 multiplied by 1, so that will be that. Next one, y0. Consider now this signal unchanged and this signal, that is a folded signal. Now consider this row and this row only, ignore all other rows. See that there are only two overlaps here. So 2 multiplied by 1 2, 1 multiplied by 2 2, 2 plus 2, it will be 4. Okay, all other things will be equal to 0. So this will be that. In this way you can find out y1 also. Y1 means you have to consider now this row unchanged signal and this row. Here you can see there are 3 overlaps, 1 1, 2 2, 3 1. Okay, so multiply individual columns and add up them, you will obtain 8. Similarly you can obtain y2 from here, that will be 8, and all other samples up to y5. And after that make the sequence by using all these obtained values, and you know that for y0 value was 4, so you have to put the up arrow here. That means it is the origin, position of the origin. Okay, it was the tabular method. And last method, it is another shortcut method of the graphical method. The last method is the matrix method. Matrix method is the most easiest and the most shortcut method. In competitive exams, generally you have to use the matrix method. Okay, suppose you have two signals, you have to make a matrix. Okay. In the rows you have to write the HN signal. Okay, its values are 1 2 1 minus 1, and the time index starting, sorry, the position of the origin was here, position of the origin was here. Okay. And for the signal xn, it was 1 2 3 1, position of the origin, it is written column wise, and its origin position was here. Okay, what you have to do, you have to simply add these two, this row and this column, write it here 1 multiplied by 1, this row, this column, so this row, this column. Okay, so what you have to write, 2 multiplied by 1. Okay, row, column, 3 multiplied by 1, row, column, 1 multiplied by 1. Okay, in this way it is the row, it is the column, so 1 multiplied by 2, 2, it is the row and it is the column, 2 multiplied by 2, 3 multiplied by 2, 1 multiplied by 2. In this way all the elements has to be written. Okay, and after that get the values. First value was 1, this value was 2, this value was 3, this value was 1, this value was 2. In this way write all the values which you have obtained individual multiplications. Okay, after doing that, just divide diagonally. First one you have to take a single element here, next one you have to take the 2 elements here, third one you have to take 3 elements here, diagonally divide this particular matrix. After that you are getting 4 elements, after that you are again decreasing 3 elements, 2 elements, 1 elements. Okay, by dividing the matrix, this sample will be the first sample, y minus 1. Okay, this one, these two samples are individual values of two samples of the y0, second sample. Okay, so add them, 2 plus 2, it will be 4. Third, this section will give you the individual 3 samples of y1. Okay, add them, 3 plus 4 plus 1, it will be 8. Again the fourth one will, addition of the fourth one elements will give you the value of the y2, that will be again 8. Value, summation of the 3 elements here will give you the value of y3, summation of 2 elements here will give you the value of y4, and last one there is no summation, only single element is there, it will give you the last sample. Okay, so all these are the values of the sample of the output of the convolution, and you know that y0 should be the position of the origin, so write those in the sequence manner and put up arrow here. That will give you the output sequence. So these are all about the linear convolution or the discrete convolutions. Prepare those because it is a very important method, and it is very important for the examination also. In my next class I will start the next chapter, that is the Z transformation.